series that we shall look at in the reasoning section is the number series. Now, as the name suggests, a number series is a series of numbers. It is a set of numbers that has a logical sequence. What you have to do in this kind of a question is to find the logic of this series and get the answer. Let's look at the different question types that can come in a number series. The first kind of question involving number series is to find the missing number. For example, you'll have a question like what is the missing number from the following series? We have 2, 4, 6, blank, 10 and 12. Now if you look at this series, it is an increasing arithmetic series containing even numbers. That is, each number is increasing by 2. So 2 plus 2 is 4, 4 plus 2 is 6, 10 plus 2 is 12. So the blank shall be 6 plus 2, that is 8. The second kind of question will ask you to find the next number in the series. In the previous question, we had a series and a blank in between. Here you'll have a series and a blank in the end, or a question mark in the end. For example, the question will be framed like what is the next number in the series? 2, 4, 6, 8, 10 question mark. So in this case, the next number is 12, that is 10 plus 2. The third kind of question asks you to find out the incorrect number. For example, you will be given a series and one of the numbers in this series is incorrect. You will be asked to point it out. For instance, here the series is 2, 4, 6, 8, 11 and 12. If you look at the first 4 terms, you see that it is an arithmetic progression where each number is increasing by 2. However, 8 plus 2 is not 11 and 12 minus 2 is also not 11. So the number there should be 10. Then the series is correct because it becomes 2, 4, 6, 8, 10 and 12. You can fit it into a logic. The fourth question type is to find out the correct number. That is, you will be given the incorrect series and you will be asked to replace the incorrect number with a correct number. In the previous question, you were just asked to point out what was the incorrect number. In a question like this, you will have to find out what is the incorrect number, but the answer will be something that will replace this incorrect number. That is the correct number that will come in the place of the incorrect number. Next, we shall look at how to solve types of number series. There are some set patterns and logics that are generally asked. So we test the number series for each one of them. There are several common types of series, that's what I mean. There are several common types of series and it is very likely that the IBPS will ask you questions from these types of series. There may be series that are not this series, but it is most likely that the series would be one of the following. The first is an arithmetic progression. What does that mean? It means that each number in a series is followed by a number that is greater or lesser than the previous number by n. For example, in the series 22, 25, 28, 31, 34, each number in the series is greater than the previous one by 3. And in the series 46, 42, 38, 34, 30, each number is less than the previous one by 4. So in this series, a subsequent term is found by an addition or a subtraction of a fixed quantity. The second kind of series is either a progressive or a regressive series. That means that the number by which each number follows its predecessor either increases or decreases progressively. For example, in the series 0, 1, 3, 6, 10, the series is progressively increasing. The first number, you add 1. For the second number, you add 2. For the third number, you add 3 and so on. An example of a regressive series is this: 50, 49, 47, 44, 40. Here, you subtract 1 from the first number, subtract 2 from the second number, subtract 3 from the third number and so on. The third kind of commonly occurring series is a square or a cube series. That is, the numbers in the series are either square or cubes of a sequence of numbers. For example, if you have a series 0, 1, 4, 9, 16, this is a series of squares, that is 0 square, 1 square, 2 square, 3 square, 4 square, etc. Similarly, the series 0, 1, 8, 27 is a cube series. 0 cube, 1 cube, 2 cube, 3 cube. Now we look at something called a geometric progression. That is, the numbers in the series are a multiple of the previous number. That is, the next number is equal to the previous number multiplied by some constant number. For example, the series 1, 4, 16, 64, 256. Here the next number is the previous number multiplied by 4. Similarly, the series 125, 25, 5 and 1. The next number is the previous number multiplied by 0.2. We have then this concept of an abstract series. That is, this series is not directly evident because it will be a combination of two or more of the aforementioned series. For example, if you have the series 1, 1, 2, 3, 5, 8. Here, there is no set pattern. It's not arithmetically increasing. It is not a cube series. It is not a geometric progression. So here you have to look for some other logic. In this particular series, the next number is the sum of the previous two numbers. For example, 2 is 1 plus 1, 3 is 2 plus 1, 5 is 3 plus 2, 8 is 5 plus 3. Let's look at the second example. The series is 1, 4, 2, 6, 3 and 8. Here you have alternate prime and composite numbers. That is, the series 1, 4, 2, 6, 3, 8 starts with 1, but after that it alternates between prime and composite numbers. Like 2, 3, 5, etc. would be prime numbers, 4, 6, 8, etc. would be composite numbers. So the series actually is 1, the first composite number, the first prime number, the second composite number, the second prime number, third composite number, third prime number, and so on. Let us look at some tips and shortcuts for solving number series. First, solve a series for at least 3 terms. That is, before you mark your answer, make sure that whatever logic you think the series follows is valid for at least 3 to 4 terms in this series. The IBPS exam has minus 0.25 penalty for a wrong answer. Therefore, it is always better to be sure of your answer rather than make a mistake. If you don't know the answer, don't answer the question. The second tip is note the magnitude of the numbers in the series. That is, see the rate at which the series is increasing or decreasing. If the rate of increase or decrease is small, the series is probably growing by addition or subtraction. If the rate of increase or decrease is large, it's probably multiplication or division. If the rate of increase or decrease is very large, it probably is a square or a cube series. It need not be definitely an addition, multiplication or a square cube series. It could also be a composite or abstract series involving addition, multiplication or square. But as a general thumb rule, the rate of increase can tell you what kind of components or what kind of logic your series has. Third, check for linearity. That is, if a series does not linearly increase or linearly decrease, it is probably an abstract or a combination series. That is, if you can't find a set pattern for which the series is growing or declining as the case may be, then the series may be abstract. You have to think of some combination or some other random logic for the series. Fourth, mug up all the squares and cubes of all the natural numbers. This will help you in recalling the squares and cubes quickly. So when you see a series of numbers, you can easily know whether it's a square or a cube.